Hello everyone, this is Super CEO back. So now today is the very first video for the part C of continuous variable. So it's mean and variance. So we're going to have a look at the first questions from the foundation part. And as usual, here's the statement from the Cambridge. All right, so the first three questions that I want to deal with today are these foundation questions, like so. All right, so now let's have a look at the actual working out for this. So question one, this is the frequency function given. It's uniformly distributed, of course, because it's a constant on that domain. So you have to show that, as usual, this frequency function is a PDF, and that's the first condition being non-negative. And within the domain, when you integrate it, and when to integrate it, you should get 1, which is the case. So hence it's PDF. So pretty straightforward exercise. Part B, you now have to find the expected value of that continuous variable x, and that's the formula, the integral of the domain x times f of x, and therefore this is a simple linear function to be integrated to get this quadratic, and evaluate 0 and 10, then you get this. So which means whatever that continuous variable is, the expected value, if you like, the average, is going to be 5. So we expect that the average value for the continuous random variable is going to be 5. Okay. Part C, the question was, does your answer for the expected value from B, which is 5, agree with your understanding of expected value as an average value? And that's my answer, yes, because the given function, the frequency function, is uniform for x equals 0 and 10, because it's flat, so therefore the middle value is the average, so as expected. Now the variance, the question says that you have to use that particular form, that is integral of x minus the mu, the expected value, all squared times the frequency function. So that's what you're asked to use, even though this is not my preferred form to calculate. So that's that one, so that, and because the stuff inside the bracket here, which is linear, x minus 5, so even if you do the reverse of the chain rule, it wouldn't affect, because it's division by 1 anyway. So that's that one. Evaluated, you get this, and that's that. And remember, this is the variance, which is the square of the standard deviation. Therefore, statistically speaking, we're more interested in the standard deviation, which is 5 on root 3. Okay, now part E, now use this more practical formula for the variance, which is that. So E x squared is integral of x squared times the frequency function, and take away EX, which is the expected value from part B, it was 5. So we just substitute 5 straight away to get the 25 there, and get the first term integrated, evaluated, then you get that, hence that's the variance. Hence, when you take the square root, you get back to 5 on root 3, which is expected. Okay, so whether you use that form or this form, you should get the same answer. But in terms of practicality, this is more preferred way of calculation. Okay, next question, question 3. This time the frequency function is quadratic, going through the origin, and that's the domain. All right, so as usual, you have to show that it's a PDF function. So by now you should be really good at this, and all right, because it's quadratic, and that's to show that that's 1, so that's 3 x squared. Now the reason I'm doing that is because x squared is an even function. So one of the properties for an definite integral is that if you've got integrand to be an even function, then you can just chop this from 0 to 1, and then you just got to double it. So 2 and 2, they cancel, give you that. All right, so that's what I mean by using this symmetry for an even function. And you get this, therefore that's 1, hence it's a fair income PDF. Now the expected value, so x times the frequency. Now notice I said straight away it's going to be 0 without even actually calculating it, because this 3 on 2x cubed is an odd function. So when the integrand is an odd function and the x value is going from negative a to a, then it's just going to be 0, because positive side and the negative side, they cancel each other out. So what that means is the expected value, or the average, is going to be 0. Okay, all right, now the variance, I've used the preferred form, that is x squared of the frequency integral divided, take away the square of the expected value, which in this case was 0. So that's that, and you get this as the variance, hence the standard deviation is that, the square root of that. And then I've rationalized it. You don't have to, but I just did it just because I didn't know what the answer had, what sort of form the answer had at the back of the book. So now part D, it was asking us to integrate it from the mu plus sigma, mu take away sigma to mu plus sigma. So basically one standard away from the expected value. Okay, one down and one up. So so that's 0 for the expected value. So in this case, it's going to be negative of the square root to the positive of the square root of that number, that fraction. And again, this is an even function, so I can chop this from 0 to root of that fraction and double it, and then twos cancel, so you get that nice non-fraction integrand. Then you get this, and evaluated it, then you get that, so which is 46.5%. Okay, moving on to question 4a. So that's the linear. I've got the sketch for it, and as usual, that's greater than 0 from the sketch, obviously. And if you integrate that, which is a simple area of a triangle, then that's 1. So that's a PDF. And as usual, work out the expected value. So that's x times the frequency function, evaluate it, then you get that. So the 2/3 is the expected value. Variance, again, I'm using the preferred form for the calculating variance. So that's that one. X squared times the frequency, take away the square of the expected value, then you get that. Evaluate it, then you get this. Notice 2 on 4 is the same as half, and common denominator stuff, then you get 1 on 18 as the variance. Hence, the standard deviation is the square root of that, which is this, or get it rationalized, then you get that. And as in the previous question, you're asked to integrate it from mu take away sigma to mu plus sigma. So one standard away from the average, the mu, or the expected value. So that's 2x, because that's the frequency function, and I know the actual substitution isn't going to be very nice. Again, I didn't have a calculator at the time that I was writing this down, so I had to do it manually, and you get that. Okay, so then you get this. So whatever the decimal value it'll give. So like I said, I didn't have a calculator, so I just had to stop there. All right, and question B of question 4, that's the absolute value now, function. So that's a nice V, 45, maintaining 45 degrees to the axis. So clearly that's greater than 0, blah, blah, blah. That's 1 PDF. Okay. And expected value, I mean, even from the observation, we can see that it's going to be 0. Okay, so that's what did that. But you can actually calculate it if you want to. And the variance is the integral of x squared of the frequency, so which is that one, and take away square of the expected value. Now, area of that triangle and area of the triangle, sorry, not the area, so that's x squared and x. Now, because of this is the same as saying that, okay? Now, of course, when x is positive, that's going to be x. When x is negative, this is going to be negative x squared. So therefore, it's the same thing as saying 0 to 1 and x cubed, and just got to double it. Okay, so that's how I got that figure. And take away 1, 0, and then you get this. Hence, that'll give you half for the variance. Hence, the standard deviation is such. And that's the average minus the standard deviation, average plus 1 standard deviation, which is this. And again, by the same argument that I used here for the absolute value, when it's positive and this is positive, when x is negative, this will have a negative there, and from 0 to minus 1 to 0, that's going to be the same thing as 0 to 1, but double of that. So exactly the same argument, so double of the positive evaluation. So then you get this, hence that's half, 50%. Okay, so last one of the question 4C. It's a different, this time quadratic frequency function. And as usual, that's a PDF exercise. Expected value, that's x, 3x squared on 64. So calculated that one like so, evaluated from 0 to 4, 3 on. Now, what I've done is, instead of keeping 64, I've changed it as 2 to the 6. 1 on 4 is 2 to the 6, because when you deal with all that 4 to the 4, that's going to be a huge number. So if you keep all these big numbers, it's going to be very hard for you to come up with the simplified fraction. So that's why I converted all these as a power of 2, okay, with the base of 2. So that's that one. If you calculate all that, and that's 3 to be the expected value, and variance is that. So x squared times 3x squared on 64, which is x to the 4 quartic, and take away this, hence gives you that for the next line. And then the next one is the actual evaluation. Lucky I've got 0 there, so I don't need to worry about the second term. Okay, so take the 5 out and expressing 64 as before, as in 2 to the 6, and 4 to the 5 as 2 to the 10, the same, and you get that, and that's 3 on 5 to be the variance. Hence, the standard deviation is this. And finally, 1 standard deviation away from the expected value, that's that, which is this, upon integration, and evaluate that into that, and you get this. And by the time I couldn't be bothered doing manually, so I had to look for my calculator, and then luckily I was able to find it and plug in those numbers, and gave you almost 67%. Okay, so that about does it for the first part of 16C, and then next video we're going to look for the questions in the development section, and I'll see you guys next time.